Eric Burgess here. We were told to check each data set for outliers. We're given 3 data sets, and in order to check data sets for outliers, we need to have the interquartile range in order to determine the fences that would tell us if there's an outlier or not. So let's go ahead and do A first. So the first step is to put our data values in order. So the smallest number is 72. After that, we've got 84. Then we've got 85, 86, and 88. I highly recommend crossing them out. It just helps stop errors. Okay, so now everything's in order, and we can begin to look at the median. So we've got 1, 2, 3, 4, 5, 6, 7 numbers. Since the number is odd, if we take 7 and split it in half, we get 3.5. We round up to 4, so the fourth number is the middle. This number, the fourth one. Knowing that, we can now split our data into 2 halves. The lower half, which include these numbers, and the upper half, which include these 3 numbers. They should have the same number in each of them, the same number of numbers. So this one has 3 numbers and the top one has 3 numbers. If they don't, then you didn't get the median correct, the second quartile, which this is what this is. So now we pick the middle numbers from these. So we've got a middle number here and a middle number here. So this is going to be our third quartile. This is going to be our first quartile. Now, knowing this, we can compute the interquartile range. The interquartile range is equal to the middle 50% of our data, which is Q3 minus Q1. If you look at a box plot, you can sort of see why this is the middle 50%. So Q3 is 97 and Q1 is 84. So whatever that is, we're going to do 97 minus 84. We get 13. So this is the interquartile range. We now create a lower fence and an upper fence. These fences, if something goes below the lower fence, it's an outlier. And if something goes above the upper fence, it's an outlier. So the lower fence is 1.5 times the interquartile range minus the first quartile. So if it's below the first quartile by 1.5 times the interquartile range, then we say that value is too low. If a value is 1.5 times the interquartile range plus the third quartile, so if it's above the third quartile by this much, then that value is too high. If we plug in, we get 1.5 times the interquartile range, which we found to be 13, minus the first quartile, which we have is 84. We're going to get the lower bound, the lower fence. 1.5 times 13 minus 84. We get negative 64.5. It's okay to have negative values. We don't have any values that are even close to this, so we don't have any lower outliers. For the upper fence, we have 1.5 times 13 plus 97. When we plug this in, 1.5 times 13 plus 97, we get 116.5. There are no values above this, so we say, therefore, no outliers. So that's part A. Let's do part B now. So part B, we again need to put them in order. So our lowest value is 115. Our next value is 119. Then we have 122. Oh, I missed a value, 118. This is why I recommend crossing them out as you go. It's easy to catch a mistake. 118. we could just put it in. 119, 122, 125, and then 145. So here's our data. We have 1, 2, 3, 4, 5, 6 numbers. To find the middle, we divide 6 by 2, we get 3. This means, since it's a whole number, there are 2 numbers that will be in the middle. It'll be 3 and the next number up. This is always true for when you get a whole number. So you would take the third number and the fourth number. So we're going to take 19 and 122, because that's the third and fourth number, and we need to find the middle of those. So we're going to use the midpoint formula. 19 plus 122 divided by 2. 119 plus 122, then we divide by 2. And we get 120.5. So the median is actually 120.5. We don't need this for our interquartile range, but figured I'd toss it in. So now that we have the median, and we know it's actually not a number directly in the data set, that means we're going to split our data set up a little differently. We're going to include these numbers, since we didn't use them directly. This is a common mistake I see, so just be careful. If you didn't use that number, then those numbers are actually still included when you split it in half. So looking at this, we have, again, 2 middle numbers that are really easy to find, since there's only 3 numbers. So this is quartile 1, this is quartile 3, and this one was quartile 2. I noticed that this case tends to confuse students when the numbers are very large. Like if you had 50 numbers, you would take the 25th and the 26th number, add them together and divide by 2. It would take forever to cross one off alternating on each side. It would take a really long time. So I really recommend getting comfortable with the logic of how this works. Okay, so we have our interquartile range. That's equal to the third quartile minus the first quartile. Our third quartile is 125, and our first quartile was 118. So we're going to do 125 minus 118, and we get 7. Our lower fence is our 1.5 times the interquartile range, the middle 50% of our data, minus the first quartile. So this is equal to 1.5 times 7 minus 118. Just looking at this, you can already tell we're going to get a negative value. It's going to be really far away, so we don't need to worry about a lower outlier. 107.5. So we're not going to have any lower outliers. Up next, we're going to have our upper fence, which is 1.5 times the interquartile range plus Q3. This is 1.5 times 7 plus 125. We're going to get a very large number. Plus 125, which is 135. 130. So we get 135.5. Any numbers that are bigger than this are considered outliers. So in this case, we see that 145 is actually an outlier. So 145 is an outlier. Maybe put a little bit more of a space between that. So there's a case where you do get an outlier by using these fences. All right, now let's do C. So for part C, move it where I can see the data. So we've got the numbers. I'm going to zoom out a bit. What's on the screen and what I can see is actually like less. You can actually see more than what I can see. So we're going to change to 13. And then our next number is 14, followed by 2 16s here and here. We've got an 18 and a 19 here and here, followed by 21, 27, 21, 27, and finally we have a 36. All right. Now let's go ahead and find them. So how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 numbers. 9 divided by 2, that's a 9, is equal to 4.5, which rounds up to 5. And just so you know, it's always going to round up because you'll end up with a 0.5 at the end. So that means that 18 is the second quartile. Since 18 was used as the second quartile, it's not included when we split the data in half. So this is going to be the lower half, and this is going to be the upper half. So we need to find the middle of these. Since there are 4 numbers, and 4 divided by 2 is 2, that means we have to take the second number and the third number, add them together, and divide by 2. In other words, we have to average these, and we have to average these. So this will give us a quartile 1 of, if we find the midpoint, it's going to be 15, because 14, 15, 16, so the middle is 15. If you don't believe me, you can use the midpoint formula, 14 plus 16, and then divide by 2. This one's a little harder to see, so we'll use the midpoint formula. 21 plus 27 divided by 2. We get 24. So our third quartile is equal to 24. Our interquartile range is the third quartile minus the first quartile, which is 24 minus 15. So if we have 24 minus 15, we get 9. Our lower fence is equal to 1.5 times the interquartile range minus Q1. This would be if a value is too low. This is 1.5 times 9 minus 15. So we have 1.5 times 9 minus 15. We get negative 1.5. Our upper fence is equal to 1.5 times the interquartile range plus Q3, which is 1.5 times 9 plus 24. 1.5 times 9 plus 24. We get 37.5. So it looks like the 36 is just barely in range of the 37.5, and there's no negative values. There's nothing close to negative 1.5. So we say, therefore, no outliers. So that's how you do questions like this. In each of these cases, we got a negative lower fence. You can have a positive one. It just so happened that we just wound up with a negative one each one of these times. So we didn't wind up with any lower outliers. If you have any questions about this, feel free to drop a comment down below, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.